And he's been working for a platform now, what, 15 plus?
Going on 12 years, Bill.
It only feels like 15.
Yeah, but I've been around forever. So good morning, everyone. I'm not in a very talkative mood right now. I came here all energetic, ready to go, and felt a little sniffly when I got on the plane, and it's gone downhill rapidly, progressed rapidly since then. So what I'd like to talk to you today is about, so I'm the original author of RTM. It's based on the Cacti open source framework. And what we did is we partnered with a company out of the UK called Ellexus, and Ellexus is into diagnostic software. And they invented a product called Mistral, and Mistral is really a product that allows you to contain your I/O. Not only monitor, but contain at a very fine-grained level. And it allows you to get better performance from your storage, not overload the storage, and then give decent reporting. In order to give the presentation, I thought it was going to be important for the maybe 0.1% of you here in the room that don't know anything about RTM, I'm just going to give you a few slides on RTM. Then I'm going to discuss a little bit about what I did with what Mistral is, and then what I did with RTM as a proof of concept. It is not generally available, and Bill and I are discussing how we can make that available if you're interested in proceeding with a POC or an evaluation of Mistral with Ellexus and IBM. Okay, so what is RTM? RTM is an operational dashboard for LSF clusters. Really, we've tried to cover as much of the ecosystem as possible. So you'll see some things on this slide deck that you may not, if you haven't looked or upgraded RTM recently, you may not know about. For example, we allow you to walk your file systems and provide reporting of your file systems. Our fault management is really spectacular, so we can notify end users and administrators and managers of what's going on in your cluster, what business rules or SLAs are in violation or nearing violation. It's a really, really robust performance monitoring, fault management, capacity planning system for HPC, okay? So it can be extended into network switches and routers. Bill mentioned Red Bull earlier this in the presentation. I went and deployed RTM at Red Bull just late last year, and within a month, they had all their network switches and routers and weather maps inside of RTM on top of what is in the default RTM. So RTM is one of those tools, you invest a little time into it, it gives you more value. And it's used in, not only for HPC and LSF, but it's used all over the world for network operation centers and other types of establishments. Even HPC outside of LSF uses Cacti, the underlying framework. So just a couple screenshots. I'm going to go quickly over this. Here we're showing top X pending reasons over time, so you know what's going on in terms of what's been pending in the cluster, where your blockage is, what's slowing down job scheduling. We have top X hosts, and we can report on multiple dimensions about which hosts are getting the most jobs, how efficient are those jobs, those kind of things. Just some nice tapestry to provide management as to the utilization of the cluster. We give you a nice, what we call a host dashboard for smaller clusters. It's kind of a little too much in the larger systems, but it gives you kind of at a glance what's going on in the machine. How busy is the machine? What's going on? We give you really, really precise fault management. Okay, we give the ability to create alert templates that can notify administrators. For example, with the Ellexus Mistral integration, you can be notified via email, or you can send a SNMP trap to an operations center if, for example, your storage is overloaded, right? You could automatically kill the jobs that are overloading the storage using our fault management system in RTM. It's very, very capable. And then we give you very, very detailed reporting as to the jobs and what they've been doing in the cluster. We provide over 100 columns of metadata about your jobs for each job in the system, and we can keep that data for up to 3 years. And lastly, we provide a roll-up of data so you can see what's been running over the last month, years, by user, by queue, by project, et cetera. So you can understand who your top users are in a more tabular format, and then maybe export that data for reporting. So that's all I had to say about RTM. There's a lot more to it, but at a high level, those are kind of the important things. Now, on to Mistral. So Mistral says, their job is to solve the noisy neighbor problem, okay? So they refer to it as groundbreaking tool to load balance shared storage. It was developed in collaboration with the IT department at ARM, and it's able to monitor application I/O performance across the cluster in order to identify rogue jobs and hotspots. It'll load balance the storage, so you can introduce delay into the I/O operations to keep your storage from falling over. And Mistral won the highly prestigious Product of the Year award from Cambridge Lab Ring Hall of Fame in 2016. So it's fairly well recognized. They've been pitching, if you don't mind that term, the Mistral product here in Silicon Valley and other areas. So it's quite attractive, and we've got some use cases as well. We didn't have those people presenting today, where they literally have resolved their storage issues that they were having prior to the deployment of Mistral. So again, it's there to protect your storage, to load balance and optimize workload. That's Mistral in a nutshell. Okay. So if we look at LSF integration with Mistral, essentially what we do is we place a wrapper around your job, and it acts like a tap or LD preload for the technical people in the room, and it basically traps all system calls and then reports violations, either an excessive bandwidth, a read or write bandwidth against a specific file system or mount point. It can report I/O latency issues as well as high IOP type counts. So you have really 4 dimensions that it can report on in terms of what happens with the relation between the job and the storage. Okay, and so an example would be a particular job. In this case, job number 42 is exceeding 500 megabytes per second to a particular mount point. And so that'll generate an event that'll get placed into a database, and then we can consume that data inside of RTM. That's basically the nut of it, right? And I've done a lot of testing, and the RTM plugin that I developed, we've scaled up to millions of events, and the performance is actually quite good in the way that it was designed. So we have a couple use cases, and the one that Ellexus likes to present is catching the rogue job. So here we have a parallel application, right? So you have a head node and you have slave nodes, and in this particular customer scenario, this is actual customer scenario where the customer's been removed. They had spectrum scale storage, which is a parallel file system, and parallel file systems have this unique characteristic where they can consume a lot of I/O quite rapidly. They're using QDR InfiniBand, so they get about 4 gigabytes per second to the node. So you can open a file, literally a single file in a streaming mode in spectrum scale at 4 gigabytes a second. So it's pretty spectacular parallel file system. And they've got 32 gigabyte slots per host. So they're using RDMA InfiniBand for communications. That's a native thing with spectrum scale. We don't necessarily use TCP or UDP communications. It's RDMA InfiniBand. It's it loosely resembles UDP, but very low latency, and it can move data quite quickly. And so they have this parallel job, and the normal I/O pattern is principally between the head node and the storage. Okay, and that's the general way that these applications are written. So 2 use cases, right? First of all, they have the poor application design. Instead of the head node writing all the log data, each of the nodes here are writing to the file system concurrently. And so you get a lot of extra I/O that you don't necessarily need. So this is one of the things that Mistral is really good at catching, okay? Second is, the administrative error. The administrator leaves the application in debug mode and overloads the storage with I/O operations, right? And so Mistral is very good at catching these types of scenarios. In the use case, they describe that the customer had all sorts of problems when they went to deploy Mistral, and a year later, no problems, everything under control. They had what they call contracts in place to ensure that the storage does not get overloaded, and throttling rules in case something gets through the cracks. So again, the Mistral solution, the same thing. We wrap the job in a job starter and monitor the I/O. And the 2 use cases that we normally see, which I thought was kind of funny down here, is my house is on fire, right? I got a call, I'm in ops, I need to solve the problem. My house was on fire, what in the heck caused it, right? So these are the kind of important things. And in normal operations, you always want to be in front of these problems, right? one of the ways to keep happy customers is by having enough information so that you're able to identify and solve problems before the user does, okay? And so good operations, IT operations, is always really kind of heavily reliant on tools like RTM and other tools in the industry to stay in front of these things. So essentially, the way you configure Mistral is you define what are called contracts. And contracts come in two forms. There's monitoring contracts, which just will monitor a specific volume or mount point and report when a job or an application or a process exceeds a threshold, and what that how it exceeded it, what the bandwidth utilization was, so forth. And the second type is what's called a throttling contract, which will, if it detects that the application is overloading storage, it will introduce delay, which then reduces the I/O load. So it basically provides the ability to ensure that no one job can take over the entire file system. And the events you can see here in the bottom, the events that it generate are fairly straightforward. This is just a subset of the events that you can see, but for example, we can see what tool is using it, what file they're writing to, the violation that they exceeded, okay, or the contract value that exceeded what it was. So what did we do in RTM, right? So in RTM, we had a couple goals, right? First of all, to provide the administrators a way to profile applications prior to introducing them into production. Second, to provide at-a-glance monitor exceptions. So like, for example, if the house is on fire, which job is it, right? I want to be able to see that within 2 or 3 clicks of the mouse so that I can take action and kill the job if necessary, okay? And to integrate with RTM's fault management system so that, for example, if you're not sitting there kind of sitting on top of RTM, you can get a notification via email or another method, so you don't have to come in a day later and see that the house burned down, but you have an opportunity to take action. Again, you want to be able to solve these problems before you get the first call from the help desk that you've got a problem in operations. And then they provide the users the ability to review storage profiles of their applications and workflows and search for solutions to those performance problems, right? I call it in, I've been doing this for a number of years. I mean, and I love to talk, but again, I'm not very talkative today. The application onboarding is a really important process in HPC, especially in my space. It's more industrial manufacturing and research, and these researchers are bringing in applications all the time. They're bringing in strays from the field, and you never know what that application is going to do until you put it out there. And so it's always really important. A tool like Mistral is really important for you to be able to see what that application does at a very precise level, so that you know before you introduce it into production what it's actually going to do to your storage. Okay. All right. So let's see a couple screenshots of RTM, right? And I think how am I doing on time, Bill? Plenty of time. So I'm ahead of schedule. So that's good. So RTM is all about tables and graphs, right? And so in this first example here, I'm showing all of the events that have taken place, and if you hover over anything, you can actually see what was going on. You can see what the threshold value is. This is the raw data, right? This is exactly all the events that have been triggered, what jobs triggered them, what path were they writing to, was it a read operation, a write operation, was it IOPS, et cetera. And again, I've ran this up to millions and millions of events, and it works just fine, okay? So the second screenshot is the same thing, but now I'm rolling it up. So I'm looking at a 5-minute duration. I'm saying which job generated the most events. Where's that hot job? From when I go into this screen, I can tell at a glance what's burning the house down right now, okay? So if I get that phone call, I can find the rogue job. And then we also provide roll-up statistics. So in RTM, we have this thing we call daily statistics. So I give you the ability to go back in time and see which applications, which files, how many I/O operations, lots of statistics about, is the trend, I'm getting more violations, less violations over the last day, week, month, et cetera. And of course, we give you the ability to export those rows into a CSV file for external analysis. And then lastly, I give you, so with the daily statistics in RTM, it's more of an accordion view, and you can roll up and see which specific user, which specific project, which specific queue was generating all the events. So in RTM, traditional RTM style, in daily statistics, I allow you to spread the data out and show you huge amounts of details, or shrink the data in all the way down to a single dimension, a user, a project, a queue, a cluster, and show me how many events in a particular contract, how many bytes, et cetera, were involved. One thing the customer who I worked with, collaborated with, to develop this really wanted to see was, in RTM we provide this thing called job graphs that show you the R usage from the launch time to the end time of the job. And we show you memory consumption, first derivative, because we're all smart and engineers here, we know what the first derivative is, of memory consumption, CPU time, S time, and U time over the life of the job in the first derivative, PIDs, PGIDs, and threads, and then the first derivative, the number of slots allocated, because a lot of people now are growing and shrinking their slot allocation over the lifetime of the job, so we want to see that, as well as the rate of change. But in this particular case, we added to this job graph a number of events and the IOPS, or bytes, that were impacted by the various contracts. So for every contract you have defined in the system where you actually have generated an event in RTM, you'll get an R usage graph, so you can look at a time series data across the job to understand when those events took place. And then, in an example that the IBM EDA team gave some years ago, they were able to actually line up the timing of this graph with their log data and find problems in their workflows and identify it. So it's really kind of adding to that, specifically, in this form. Okay. So when you open that page in RTM, you'll see that data. The other piece was, give me a tabular view of that graphical data here, and that's what this Mistral Events tab here is on the far right. Okay, and you can see here, I had actually set up this test case to generate huge numbers of events. You may not see this in a typical Mistral setup, but there's, I think, any one of these jobs they were running for 24 hours, and they generated, anywhere between 500,000 and 1 million events per job, just so that you could have something to see. So that's in it in a nutshell. So if there's any questions, I'll take those now. Yes, Suba. So so RTM is based on the Cacti open source framework, and the Cacti open source framework supports what's called a plug-in architecture. And so this particular functionality was added to RTM as a plugin. So it's a standalone plugin in RTM. In order for you to install it, you'd first have to get access to it from IBM. In order to actually use it, though, you need to have the Mistral plugin, which is an extension of the Mistral product delivered by Ellexus. So if you were wanting to evaluate something like this, you would first contact Ellexus and request a demo, and then or a POC of that, and then if you have an RTM setup, you'd want to engage with the product team, because again, it is not released in IBM, and there's certain rules we have relative to releasing this type of stuff. And Bill and I have not gotten to that point where we could actually, I could just flip this thing to you, if you don't mind the term, to start using it. So Bill and I still have a few hurdles if you want to get access to this for your own environments. More questions?
If I hear you right, the business model will be, in order to use Mistral, we have to basically have separate agreement on the business side with their product.
Yeah, that's correct. Mistral, Ellexus sells this product, and we simply integrate with it in RTM. More questions? Don't be afraid. Okay. Well, thank you very much, folks. And now I can go back to being sick. So, and turn it back over to Bill.